Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how in Python to create a main method. So here we have a program that we're working on, a pizza order program, and it's importing the pizza class here. And it has a pizza order functions library that are really just kind of supporting utility functions for the pizza order program. And what we're going to do is clean this up a little bit. You can see here where I ran the program already. Welcome to Super Pizza Point of Sale System 3000. We added a pizza. It successfully added the pizza, then we quit the program. So we have a working program, but it would be nice to kind of take this and maybe simplify it even more. So what we can do is up here, this is everything here that starts indented with zero indentation is in the main scope of the program. And everything else that we're calling as functions is actually in this functions library here. And so to clean this up a little bit, what we can do is first we can write some code to see what scope this program is running in, and whether this is being run as a program or being used as a library. And to do that, what we do is we say if _name equals _main, then do all this stuff. So I'm going to take all of this and tab it in. So I've tabbed it in one more. I highlighted it all and hit tab. And so now what this will do is it will check to see if we're running in the main scope. And just so that we can see well, let's see. Yeah, let's just run this and we'll see that it doesn't really change how it runs. And yes, you can see the program works just fine. Let's run that in debug mode to see what's going on. So I'm going to run that in debug mode. And let's look at this special variable. Notice it's main. In fact, you can see it up here, I believe. Yes, right there, name. This is running in the main scope, so it's actually main right now. To kind of demonstrate how that's different than normal, I'm going to go into the Python interpreter and I'm going to say import pizza order.py. Oh, import pizza order. Okay. Notice that none of this stuff actually ran. Let's do this. Let's print. We're going to just print this at the very top of our program. Let's save that and run that and then do that again. Let's see. Oh, let me close this out. So there we can see when we run it here, it's in main. And there, so when we ran it as a program, it said main. When we ran it as an import, it said pizza order. So what this does is essentially makes it so that if you bring this file in as a module, it won't do all of this stuff. If it's running as a program, it'll actually execute this as code. So this is useful on one instance to make sure that we're not going to do all this stuff unless we're actually running as a program. So that's one way of doing this. Now, to kind of simplify things even more, one thing you can do is you can go into here and you can actually, or actually let's start off here. We could define a main method. And rather than doing this is all our code is now part of this main method. And then down at the bottom, we could then just call our main method. So now at the bottom of our program, this is what determines if we're going to execute the main method. Here we have a main method. And so this will define the main method, and then we won't actually execute it unless we are in our execution context is that of a main program, or it's being run as a program. So I'll run in debug mode again, and we'll see what this does. Try it again. And here we are at main. So this became true, and then we ran in main. And now what we're going to do is we're going to step into that function. Now it starts executing our main program. And so this is a way of, again, kind of separating things out a little bit more and making it a little bit more concise. You could even move your main method to your library function. If you wanted to. That's probably overkill. And that would, if you did that, it would leave your program, very sparse. So this probably makes sense. Let's just do that. So in any case, to make a main method, check the execution context and then call main in your program and put all your main part of your code in this main method. Another aspect of this is if we look at our pizza class, we had a pizza test program. We could actually, rather than importing pizza and putting our tests there, we could actually do this. We could take these tests and we can actually put it in our library. And we could say, if this is being run directly, what I want you to do is run my tests. Now, because we're directly in this class, we're going to change this. We don't need to reference a library. So we're just, because we're in the library, we're going to get rid of this extra reference to pizza because pizza is right up here. That's pizza. So I'm going to get rid of that. And so I have basically all these test programs. So now what I can do is I can actually run this. And it's running all my tests here. But then when I run my pizza order and it's importing it, notice it doesn't display those tests. So what's nice about this is if you're the person writing this class, you can write some little test cases for your pizza class as long as you put them in that name check there. That will only be executed when you run your library. Otherwise, when it's being imported, these won't be run, but they'll still be here so that you can check that if you need to go back and check to see if your code is working okay, the tests are in the same library. Now, there's so that works okay. But it'd be nice if we didn't have to go and look at this code to see if it worked all right. Well, we can use something called an assert statement. So what do we expect? We expect that if first piece of summary should equal this. So rather than doing a print, what I'm going to do is I'm going to do what's called an assert statement. And we're going to assert that this is equal to that. So let's stop this and then let's run this again and see what happens. Okay, well now it's not displaying it. So how do we know that this is working? Let's put a little, let's see. Here's our summary. Let's say we were to modify this and put an error. This, we have an error in there now. Let's run this program. And notice that when we run this program, it tells us, hey, there's an assertion error. This didn't do what we expected. And then you would say, oh, we accidentally entered some information. You would then rerun it and it would work fine. So we can do this with all of these. We can turn these into asserts. Or, well, before we do that, there's one other thing we can do with this. We can actually make a custom message for this. And the way we would do that is we would maybe make a format string and said expected and got In order to do that, we need to use parentheses with it. In order to have a custom message, you have to put this in parentheses. So basically what this is saying is, hey, to do this check, if it's incorrect, print this error. So let's put our error back into our code and then run this. Expected, let's see, what? And then we can continue on and do the same thing with the others. So let's put in a search statement. and do it with all of these. So we have now all of these assert statements in here. If we're in main, we're going to run these asserts. And so if I run this, okay, that's good. If I have a broken piece of code, it'll stop until there's an assertion, tell us there's an assertion error so that there's something wrong with the code. And what I can do is at the very end, if I wanted to, I could just put a print all tests passed. Now there's a lot of complexity in writing test code. There's actually a whole there's a lot to learn related to this. This is just a very simple example of how you could write tests for your library, and you could embed it into your code so that it can be very quickly passed. After, if someone modifies this library, they could run it and make sure that previous things that are required are not, that those still passed. And you can even take these and turn them into test functions. You know, for example, you could say define a method, and often if you write a test method, that's pretty verbose. And so here, actually maybe call that default pizza. That's the default pizza. It should return that. And then we can just call this test method. And then we know that, and this also gives you the opportunity to put in, comment, what the reason for that requirement is, and then this ensures that that is in place. Now, if anyone changes the code and it changes that, they have to contend with this test piece here to confirm that that is. So you could actually go through here and take every requirement that the user gave you, make a test for it, and make sure this library does that behavior. So this is one way of automating the tests. These are often called unit tests, and it's a good practice to do that. And I would probably put a comment here, just saying tests. And then we see all tests passed. We're good with this one. This library is pretty complete. So that completes how to write a main method, how to use the name special variable to verify what your execution context is, and then use that execution context to write tests for your class to make sure that if any changes happen, you can detect them. And if you think about this, if this test failed, another program could come in here and say, oh, the customer wanted the, and you could even put in a reference to the conversation at the time or the date, whatever that is. And then they would know that, they should put that back, or they might go and confirm that the customer still wants that. And if they didn't want that and they needed to change, they would then change the test to make sure that this library continues to do the default. So let's say they come in here and say, I want this to be a deep dish. And they say, okay, we made a modification. Let's run our tests. Large thin crust pizza with cheese. That's an assertion error. What's going on? Oh, okay. The customer wanted that. Okay, we can't change that. So then they go back, put it back, and then the tests pass. So those are common things that we want to do with software to make it reliable. Thank you very much.